May we please have a drink of water, Uncle Bob?
You certainly may. That's one thing I have plenty of. Help yourself.
Boy. I'm next.
All right, plenty for everybody.
I'm next.
Well, what's this, the seventh inning stretch?
No, we were just practicing. Boy, this water tastes good.
Boy, nothing like water when you're thirsty.
Oh, you're so right, Mike. You know, man can add all sorts of things to water to make it taste differently and have pretty colors. But when you're really thirsty, boy, you'll choose just plain old water. Say, by the way, do you fellas know what water's made of?
What do you mean, made of? You mean water's made out of something else?
It is that. What do you think water is?
I always thought water was just water. Yeah, just plain H2O.
Ah, there you are, Ted. Okay, now what do you mean by just H2O?
I don't know. I guess it's sort of a nickname for water, isn't it?
I guess H2O has become sort of a slang expression meaning water. But actually, H2O is the chemical formula for water. But why do we use the letters H and O with a little 2 in the middle?
I don't know. Tell us, Uncle Bob.
All right, I will. Come on into my lab for a few seconds, and we'll do some detective work and solve the mystery of why we call this H2O. Huh? I'm going to need a fresh supply of Exhibit A. Go ahead in.
Thank you.
All right, now you fellas just gather around the bench here while I go back to the electrolysis equipment.
The what?
Electrolysis equipment, Ted. That's what we call this glass apparatus that we're going to use to perform the experiment. Now, I'll need some power. Bobby, in over by the radios on the back shelf, you'll find a Super B battery. It has some leads attached to the top terminals. Would you get it for me, please?
Yes, sir.
Now, I'll add some more water. There.
Just one, Uncle Bob?
Yeah, that's it, Bobby. Fine, thank you. Okay, now, fellas, I want you to watch these little platinum electrodes in here very, very closely. Because when I attach the battery, the current will flow through the water, and you'll see something very, very special start to happen.
Hey, look at the bubbles. Yeah, look at them.
Right. Little bubbles are starting to form.
Where did the bubbles come from?
Aha. That is one of the wonderful secrets about water that we'll soon find out. Now, notice that the water level is going down in the tubes. As the bubbles continue to appear, the water disappears. Now, what do you suppose that means? Well, this may come as a big surprise to you, but the electric current running through the water is breaking the water down into the two things from which it's made. In other words, the water is being taken apart, and we're left with the two elements which used to be the water, two gases. Now, the bubbles of one gas collect in the top of this tube, and the bubbles of the other gas collect over here. So you see, fellas, water is really just a combination of two different gases.
Wow. Two gases. I mean, water is just a couple of gases that are put together?
Right, Bobby, that's it. But those gases must be put together in just exactly the right proportion. Now look at these tubes again. Do you notice any difference between them?
Yeah, there's more water in one tube than there is in the other.
Right you are, Ted. That means there's more gas forming in the top of this tube. And you notice there's twice as much gas in this tube as there is in the other one.
But how do you know which gas is which?
Well, that's a good question, Milton. Let's make a few tests, huh? Now, first of all, we'll let the gas out of this tube and see what happens. There, you see how that burns with a light blue flame? You have to look pretty closely because it's invisible. Well, we know that hydrogen burns with an almost invisible blue flame. Therefore, this is hydrogen. All right. Now let's test the gas in the other tube. There. You see how that spark on the end of this piece of wood burst into flame and burns very fast?
Yeah.
That's because that spark has come in contact with oxygen. Now, oxygen itself doesn't burn. However, it enables other things to burn. So, by this experiment, we know that water is made up of two gases, hydrogen and oxygen. Now, the chemical symbol for hydrogen is the letter H. And to represent oxygen, the letter O is used.
Well, we call it H2O. What does the little 2 mean?
All right, remember that we decided that there was twice as much of one gas as there is of the other? Do you remember which one?
Well, this one has twice as much gas in it.
Uh-huh. And do you remember what happened with this tube?
Well, this tube had a blue flame on the top.
Right.
Hydrogen.
Hydrogen, right. Twice as much hydrogen as there is oxygen. And in order to represent that in our chemical formula, we use the little number 2. H2O. In other words, 2 parts of hydrogen combining with 1 part of oxygen makes up the wonderful substance we know as water.
How about that? We use water to put out fire, but it's made from 2 gases which burn like crazy.
Well, almost, Mike. Remember that oxygen just helps other things burn. No, water is a very remarkable liquid. All life depends on it. And you know, water is a wonderful example of the Creator's great wisdom and careful planning. And the ways in which our water supplies are regulated and maintained is another remarkable story. You see, about 3/4 of the entire surface of the earth is covered with water. The rivers and the lakes and the oceans and the streams. But as you know, the snowflakes and the raindrops that are formed in the clouds above the earth are formed from water that is in the air. Rising from the surface of the oceans and lakes and rivers and streams are tiny particles of water, which usually are so small that you can't see them. Water in this form is called vapor. And the process by which water changes from a liquid to vapor is known as evaporation. Sometimes, however, this water in the air can be seen. And these particles are now droplets of mist. But whether you can see it or not, there is always water in the air. And under the right conditions, the water vapor will turn into a liquid. You can see evidence of this on a blade of grass or the petals of a flower. It all depends on the temperature and the amount of water in the air. The process of changing vapor to liquid is called condensation. The same thing is happening up in the sky when the clouds form. As the warm, moist air rises, it begins to cool, and the water vapor in the air condenses into little drops of water. As the wind moves the clouds along, the drops of water grow bigger until they become too heavy to stay in the air any longer, and down they come as raindrops. Or, when the conditions are just right, snowflakes are formed which fall silently to the earth, where they remain until the warm rays of the sun cause the snow to melt. Little drops of water form rivulets, and the water pours into streams that go rushing and tumbling down the hillsides. Finally, the water is sent splashing into irrigation ditches where it bubbles out to soak deeply into the ground. Here it is taken in by the roots of thirsty plants, plants that bring forth blossoms and fruit of every kind. The water freshens the barren earth, changing it into a land of plenty. Another way in which water serves our need is power. In olden times, water was used to turn water wheels to grind the grain and cut the lumber. Today, the old water wheel is gone. But the power is still there, turning modern water wheels. The huge turbo generators that change that water power into electrical energy. Energy sent along wires to places where man puts it to work in thousands of different ways every day. And when the day is over, the power from the water lights our homes and our cities.
You know, I never thought about water that way before.
Neither did I. I just drank it and forgot it.
Yes, I guess most of us never stop to realize what God has done for us by giving us water. We don't appreciate how much this common, ordinary substance means to us. We're so used to it, we just take it for granted. But it helps grow the food we eat. It provides electricity and steam for power. We use it to keep things clean. We boil things in it to sterilize them and prevent disease. We drink it. We skate on it. And we swim in it. We make snowballs out of it. We use it for cooking. And we keep things cold with it. Yes, water is essential to all life. Without it, there would be no grass or trees or any living thing. For without water, you and I wouldn't be alive right now. You know, it makes a person feel very, very grateful for water. Two colorless, tasteless, odorless, invisible gases combined in just exactly the right way to give us this wonderful, life-giving liquid. Just plain old